my presentation on assessing the bioaerosol with the WIBS and the traditional offline methods. Okay. Yeah, so here's the outline of my presentation. And the bioaerosol are tiny particles suspended in the air, and they're all over the places around us. They can be generated by humans or naturally generated. And they can have a huge impact on the environment and also on human health, causing respiratory issues, including asthma. We are interested in the built environment because, as we know, most people spend more than 90% of their time indoors. The COVID-19 shutdown has caused an exacerbation of this situation, where time spent indoors is well over 90%. And we are interested in home healthcare workers because at that time of shutdown, they continue going to homes, the private home, which are not considered home workplaces to take care of their patients. So we think that the exposure to bioaerosol may increase. So our central hypothesis is that bioaerosol level will be higher indoors due to human activity during the COVID-19 shutdown compared to outdoor. There's no study has looked at the assessment of the bioaerosol in private residential settings and as applied to home healthcare workers. So our purpose is to assess the indoor and outdoor bioaerosol of the residential area during that time, going through from July through September 2020, and to see their characteristics and compare the real-time methods and the traditional methods. So our objective has three specific aims. The first one is to assess the bioaerosol level and the characteristic indoor and outdoor using the WIBS. The second one is to compare the real-time fluorescent-based WIBS with the traditional offline methods that include the cultivation microscopy, qPCR, and the next generation sequencing. And the third one was to investigate the correlation between bioaerosol concentration measured with the WIBS with the black carbon concentration measured with the PATS. But for this presentation, we'll only focus on the first two specific aims. So this is the study design where we assess bioaerosol indoor and outdoor residential sites. We continuously monitor the bioaerosol with the WIBS, and we sample air with the Batten allergen code Anderson impactor. And we quantify those bioaerosol. We use qPCR, we use microscopy, and we use next generation sequencing. And for data analysis, we compare indoor and outdoor level and characteristic, and we look at the correlation between the WIBS and the offline methods. So here are the instrument and the devices that we use: the WIBS, the Batten, the allergen, and the two-stage Anderson impactor. And this is the layout of the setting. The instrument is outdoor and the indoor here. So one thing to note is that the site is located between a highway and a major road. So result of M1, the daily averages. When we look at this total particle, we notice that the concentration are higher indoor compared to outdoor, and significantly. And when we look at the total fluorescent particles, which are part of the total particles, we observe the same thing. It's that the indoor is significantly higher than the outdoor. And when we look at the time series, the graph here on the right and at the top is the total, and at the bottom is the total fluorescent. We see that they have the same pattern if we look at the indoor one, which are the plain lines. And we see the same pattern with the outdoor. So when we look at the aggregate hourly averages, we see that the total particles and total fluorescent also still have the same pattern. And with indoor, we have some peaks at 9 o'clock and around noon. So what we can observe here also is that the indoor concentration have a lot more of variability. So the WIBS gives us the ability to classify the fluorescent particle into 7 categories: type A, B, C, AB, AC, BC, and ABC. And this is based on the fluorescent emission bands and the particle size. So here we can see that the type A dominate largely and significantly in outdoor, followed by the type B, C, and BC. And when we look at the outdoor, type B, type BC, and type ABC were dominant. One thing to note here is that it's only with the type ABC that the outdoor is a little bit higher, because it's not even significant. We look at the size distribution, and here we can see that indoor, the size varies from 1 to 2 micron average here in indoor. When we take a look at the color scale, it was the volume concentration. And with outdoor, it spans from about 2 to 4 micron here. So for the result of M2, we want to compare those offline traditional methods with the WIBS. So here we were looking at the WIBS fluorescent types with size greater than 2 micrometer and size less than 2 micrometer. So here, all you can say is that there's a positive and a significant correlation with the fluorescent particle less than 2 micron was associated with the indoor bacteria with the Anderson method. And in outdoor, we see the significant correlation with the greater than 2 micrometer with the fungi Anderson and bacteria Anderson. So what we can say is that the daily total particle and total fluorescent particle, that the indoor concentration were higher than the outdoor. And for the hourly particle and total fluorescent particle, we have the similar pattern indoor with the peaks around 9 a.m. and noon. For daily fluorescent types, all indoors concentration were greater than the outdoor except for the BC. And fluorescent type A dominated indoor, whereas ABC dominated outdoor. So another important information is that the fluorescent particle of size averaging 2 micrometer indoor and 4 outdoor. For M2, the positive correlation with the WIBS fluorescent and the bacteria was observed with the Anderson method. So as discussion, we can say that the high bioaerosol concentration might be due to human activities generated by summing of clothing, furniture, or by resuspension of particles. And based on the chamber catalog put down by Hernandez, we can say that the type 1 fluorescent particle are mostly bacteria, whereas the type B are fungi, and B and ABC are mostly pollen. So another important information also is that the fluorescent particle are mostly of in the category of PM 2.5. So they are potential to cause respiratory issues. So another one is that the Anderson, the WIBS was able to detect most of the Anderson detection also. So the significance is that home healthcare workers should be aware that there are risks to be exposed to bioaerosol in visited homes, and that most bioaerosol indoor are in the category of PM 2.5. So there's a high potential to develop respiratory issues. And we recommend that home healthcare workers, when going to homes, they may be protected by assessing the bioaerosol in the homes before they attend it, and do so more often. So some limitation is that our measurement has been taken in only one apartment, so it was difficult to generalize our finding. And we also suffer of sample size, which are small for some traditional offline methods. But as strength, we have used a cutting-edge instrument, which is the WIBS, and this is the first time where we're comparing a real-time fluorescent-based instrument, the WIBS, with 4 different traditional offline methods. And this finding will serve as preliminary data for larger studies. And for future research, so we can assess actual homes, the home healthcare visit to assess the bioaerosol and other air contaminants. So we also want to evaluate personal exposure to bioaerosol and other contaminants to the home healthcare workers. And for the long term, we want to help develop guidelines and standards to protect home healthcare workers. So there's a thank you to NIOSH and Droplet Measurement Technology. Any further questions? Thank you.
Okay, we have time for one question. And a reminder to complete Yao's evaluation. Any questions? Okay, get awful easy.
Hey, Kermit, Nick
Yes.
Newman has raised his hand.
Oh, I didn't see it on my thing. Okay, Nick, go ahead.
Yeah, I had a question. Very good, Yao. I was wondering if you had an activity log in the home that would give maybe some insights as to what activities indoors might be producing more of these particles, given that there seemed like kind of limited time periods that they were high.
Yeah, yeah. We do have a lot of activities like to going in and out when doors are open, etc. And for the peaks that we point out for our aggregate hourly, we estimate that the 9 o'clock will be about the time where the kids, because we have 2 kids in the house and 2 adults. So I think that around 9 o'clock will be pretty much the time where the kids are very active, resuspending, because we are in the carpeted floor also. So resuspension will be a big impact. So it will be due to the kids' activity around 9, and around noon, within that, some of the cooking might contribute also.
Okay, thank you.
Yeah.
We
Thank
need to
you.
move on to the next one. You want to stop sharing yours?
And
Michelle can start sharing his.